Hello everyone. I'm Adeola. I'm 16 years old, and today I'll be talking to you about solar technology and how we can really take that to its fullest potential. So, if you know anything about me, you know that I live in Vegas, and if you know anything about Vegas, besides its numerous hotels and casinos, you know that it's very hot and very dry. So it can get really hot, and especially in the summer, it's a complete desert. And then all of a sudden, last year around February, so like the beginning of spring, something really weird happened. It snowed. And for context, the last time it snowed in Vegas was around like 2008. And I was literally so confused because I was like rubbing my eyes and I was like, why is there white instead of, the brown dirt and all of that? It's snowing. And as I grew up and I kind of over the year did more research about all of this, I realized that the reason for all this different weather changes is because of climate change. Right now, this is our world. The beauty of the Eiffel Tower is being covered up by the bunch of dirt, the dust, all this pollution and all the gas. The people there can't even properly enjoy it because they have to cover their noses and their mouths with masks as well. This is the way it is right now. This is our world. Every year, 36 billion tons of carbon dioxide is emitted, just from human activities and other sources. This adds to air pollution. As a result, causes 4.2 million deaths. This is greater than the entire population of the state of Nevada. That's how big this issue is. And global temperatures in total have increased by 1.6 degrees. And this is really bad because this shows that the climate crisis is not just affecting and killing human lives, it's also really affecting our ecosystem, our environment, plants and animals and all of that. And this is the state of our world as it is. But my purpose here isn't to tell you how gloomy the present is and how bad everything is now. It's to tell you how great the future can be. Because you see, this can all be stopped. All of this can all be stopped. And in the future, we can have a brighter one. We can have a brighter future. And scientists right now are doing tons of research to find new innovations, new creative ways to use technology to find a solution to this issue. But one particular type of technology that I'm super passionate about that I'm going to talk to you guys about today is solar technology. So this, as you all know, is a solar panel. And the solar panel holds the key to unlocking a future in which renewable energy technology replaces all use of fossil fuels. For those of you who don't know, solar panels are the most efficient type of renewable energy technology that we have right now. And so by really innovating and really finding ways to improve the way it is right now, we can truly find a way to make solar panels more efficient and find a way to have a higher, more greener future. So solar panels have the capability to meet 100% of a household's electricity consumption. Additionally, solar panels, like in the US alone, the use of them has offset over 70 million tons of carbon dioxide just because of the fact that they're being used in the US. That's how effective they are. And notice I bolded the word capability though. Yeah, solar systems have the capability to meet 100% of a household's electricity consumption. The only problem is we're not there yet. The truth is solar panels are not as efficient as they could be. Yeah, I know. I did mention that solar panels are kind of the most efficient type of renewable energy technology we have right now. But still, that doesn't mean they're not at their fullest potential yet. But before I go too deep into that, what exactly does it mean for a solar panel to have a certain efficiency? So solar panel efficiency is how much of the sun's energy that is hitting a panel is converted to electricity. For example, when a particle of light or a photon hits a solar panel, it's meant to be converted into electricity. However, that doesn't always happen. Some of these photons of light can either be absorbed or they can be reflected, and a lot of stuff can happen. So we call the amounts of photons that are actually converted into electricity, like how efficient it is. So most solar panels right now only have around a 15 to 20% efficiency. And this can actually be really greater. We can truly get to 100 if we work on finding ways to make them more efficient. And one of the key ways that scientists have been doing that is by using a new groundbreaking material called graphene. And graphene is a nanomaterial made up of a single layer of carbon atoms packed together in a hexagonal shape, which may make absolutely no sense, but let me break it down. Graphene is essentially a really special type of material that's only around 1 atom thick, so it's really tiny, and it has so many different properties that can be used not just for solar cells, but for other types of technology as well. Graphene can be used just like all types of stuff, and it has 3 special properties that make it especially useful for solar panels. It is incredibly strong and has been notably mentioned to be stronger than even diamond. It's conductive, so it can conduct electricity, and it's very flexible. So now we can put solar panels anywhere and not just limit them to one space at all. So before getting into how graphene could help, it's important to understand how a solar panel works. So this is 2 pieces of semiconducting material. So like a solar panel consists of different solar cells that are put together in order to make the entire panel. So inside the solar cell, this is what's in it. So it's like a sandwich, essentially. So there are 2 pieces of semiconducting material, and this means that they can conduct electricity and help the solar panel create electricity. However, in order for them to do that, they have to have different charges. It's like a magnet. In order for them to create an electric current, they have to actually have different opposite charges. And we do that by utilizing their electrons. For those of you who don't know, just to remind everyone who hasn't taken chemistry yet, electron is a negatively charged subatomic particle that sits on the outer end of an atom, as you can see in this picture right here. So electrons, basically, the more of them there are in an atom, the more negative it is, and vice versa. The less of them there are, the more positive it is. So in order to utilize this electron, in order to create the opposite charges that are in the solar cell, we have to dope the semiconducting materials. And what that means is a process used to change the number of electrons and holes in a semiconductor, which I'll explain more later. So in order to create the p-type layer and the n-type layer, which are the negative and the positive, we, like I said, have to change the number of electrons. So we dope the n-type layer with something like phosphorus, which has like if the semiconducting material was silicon or something similar to that, we would dope it with phosphorus, and this phosphorus essentially helps when they bond with the silicon, essentially causes it to have more electrons and like an extra electron that's not bonded to the silicon. And then the p-type layer is the opposite. It has 1 less electron. So when it's so the boron has 1 less electron. So when it's doped with the silicon, it actually causes it to have like 1 missing electron that's not bonded with anything. And this is what scientists call a hole. So then in order to create an electrical current, what happens is that the extra electrons in the n-type layer have to fill in the holes in the p-type layer. And then this movement causes an electrical current that can be turned into electricity. In order to do this, a sun's photon has to actually hit the solar panel, and then this causes an electron to be knocked out of the n-type layer and moved down to the p-type layer where it can fill the hole. This process is known as the photovoltaic effect. And so when we think about it, if we can increase the photovoltaic effect more, then we can increase the efficiency of the overall solar panel. So that's what we're trying to do here with so we can increase the efficiency with graphene. So graphene is notably more effective in like organic solar panels and dye-sensitized solar panels as well. So an organic solar panel is essentially a solar panel that has organic carbon-based materials so that it can so that it's more like environmentally friendly, and also has the potential to be more efficient than traditional solar panels that use silicon. So here's kind of like the diagram of an organic solar panel. We have an electrode on top, and where the p-type and n-type layer are, that is called the active layer, and that's where the electrons do the movement. So the sun's rays go through the glass and go through a transparent conducting oxide, which helps conduct more electricity, and moves down to the active layer where the electrons will start moving, and then it can go out through the other end of the electrode in order to power other things. So this is how it works. The most commonly used transparent conducting oxide is indium tin oxide, or ITO. It's known to be very conductive and transparent so that it doesn't reflect more of the photons. It actually can absorb them into the solar panel. And so it's conductive, and it's but the problem with ITO is that it's very brittle. So say you wanted to put it on something like your smartwatch, it could break very easily and it wouldn't be able to work. So that's why researchers have recently found that you can replace this ITO with graphene, which increases the overall cell efficiency. And a lab at MIT found the efficiency using this method varied from 2.8 to 4.1% per cell. So that's actually pretty good. And if we do continue to do more research, we can find a way to reach the maximum potential per cell, which is 10%, using graphene. Another way graphene can be used is in dye-sensitized solar cells. So dye-sensitized solar cells work similarly to the solar cells that I mentioned earlier, except there's dye in them, and it kind of performs like photosynthesis. So the dye absorbs the sun's photons and then transforms it to titanium oxide. The titanium oxide is what actually kind of conducts it, causes the electrons to move, and then the rest of the process happens. So graphene can help here by being used with titanium oxide, because remember I said graphene is actually really conductive, so it can be used to help improve the efficiency. And it's been found in some studies that it can increase the efficiency of the solar cell by 52 times. So this is really important and really impressive, because if we can get to 100% solar panel efficiency, that means we no longer have to rely on using fossil fuels to actually power our world, because the burning of fossil fuels is how we get electricity most commonly now. So by switching to this, we have a cleaner, greener way in order to do this. The future of solar cells is so big, and like I'm just super excited for what is there and what can the research will bring, because this is only some of what the researchers are doing, and there's tons more methods that people can use with graphene in order to take the solar cell to the fullest potential. Now, this is what researchers are doing. This is what scientists are doing. But what about everyone else? What about the people who are at home who aren't exactly scientists and can't have access to a lab? There's tons of things you can do, because every little thing you do to help stop the climate crisis actually really builds up and allows everyone to like have a better future. Here are some five action items that you can take home with you in order to actually help work towards a greener future. 1, buy a solar panel for obvious reasons. Like I said, solar panels can potentially cover 100% of your household consumption, electricity consumption, for a cheaper price as well. And they're just they can, even though they're not at 100% efficiency, they're still pretty good as we have them right now. So maybe buy a solar panel. 2, change your light bulbs to LEDs. LEDs actually use less electricity than light bulbs do. Wash your clothes in cold water, because the process of heating up the water to wash your laundry actually uses a lot of electricity than you might think. Work in natural light, so you won't have to turn on the lamp and you can just enjoy the outside light. Finally, unplug electronics you're not using. This actually, a lot of people don't know, but this actually uses up a lot of electricity if you're plugging in electronics and you're not using them. So make sure to unplug them. When everyone takes part, this is the future. Like I said, researchers are working super hard in the lab to make graphene-based solar cells become possible. And when you do little things to help support this effort, this gives us an opportunity to make a better future for our upcoming generations. Everything you do is super important, and every little step you take makes an impact. So make sure to do all these little action items, and you can contribute to helping make the future a lot greener. Thank you. So now I'll be taking any questions if anyone has any. Okay, so how to solve the problem of grid infrastructure. Could you explain more about what you mean by that? Okay, so I don't really, like, I wish I could get more details on the question, but I'll move on to the next question. So, do you use graphene to other alternative energies you're working on? So, as of now, I've mainly been focusing on how graphene can be used in like solar panels because I found like that's where the focus has mainly been. I'm not sure how it's being used, like, for wind energy and other types of alternative energies, but I do know it's being used for stuff like energy storage because, like I said, it's very conductive, and a lot of scientists are really looking into how we can use them for lithium ion batteries as well. How else are scientists using technology to combat climate change? So this kind of goes into the last question that was asked. Like there's other alternative energies like wind power, like I mentioned. And then there's also like other ways, just like cellular agriculture, which I've also been recently looking at. And like, the agriculture of the greenhouse gases that we have currently. So by finding ways to create like meat and milk and eggs and other types of agricultural products in a lab, we can limit the amount of greenhouse gases that are produced. So how did I get into solar power research? I'm in this program called TKS, which is the Knowledge Society. And what we do is they kind of just give us a lot of skills and a lot of resources that we need in order to teach us how to solve the world's biggest problems. So I saw that one of the world's biggest problems we're having right now is like the climate change, and I got really interested in finding different ways to solve it. And I just finished my cellular agriculture kind of era, I guess you could call it. Moved on to solar technology, and now I'm currently doing that research right now. So that's how I got into it. How does efficiency help reduce greenhouse gas emissions? So for solar panels, when they're more efficient, that means that they're taking more of the sun's photons that are hitting them and turning them into electricity. So if a solar panel is less efficient and it's only taking like 2% of the photons hitting it and turning it into electricity, then you're going to need more solar panels to power a specific house, let's say, for example. So if it's more efficient, then it doesn't need as much time and as much solar and energy in order to be converted into electricity. Yeah. Are there any other ways people can get more involved to stop climate change? So yeah, there's several ways. There are the 5 ways that I asked at the end of the slideshow. But right now, I'm also thinking that there's other ways you can do, like, maybe do your own research about solar technology or whatever kind of renewable energy technology you're in. Like I said, buy a solar panel for your house because that one decreases your electricity bill and all that stuff. Also on my LinkedIn, I my LinkedIn and my Medium, I also have a lot of resources that you can read and send to people to increase more awareness about different solar and technologies. So the power grid has remained unchanged over the past century in the US, and it cannot support increase of demand. So wondering what would happen with the increase of solar energy. What I'm thinking is that if I think with the transition to more and more types of solar energy and other types of renewable or alternative energies, what we'll find is that if they're more cheap and other stuff, more people are going to be buying them. So I think as a result, the power grid would be kind of forced to change as we transition more into that like area, if that makes sense, because by having more people buy solar energy or using wind power or hydropower and all that stuff, if more people are using it and more people are paying for it, then transitioning to it, we'll have to see a change in the power grid so it can support it. Like that's kind of how I think it's gonna go. So yeah, so that's kind of my opinion in that. Any other questions? Yeah. So I guess I just kind of wanted to talk about now, because I talked about solar technology. There's other types of technology as well. Like I mentioned earlier, I just finished my cellular agriculture sector, and I kind of wanted to talk a little bit about that, because along with increasing our use of alternative energy, another way to increase to decrease the climate crisis and actually bring people and actually like create a better future. One of the ways is by changing the future of food. And cellular agriculture, for those who don't know, is kind of like are using our knowledge of science in order to actually are using our knowledge of how cells work in order to actually produce food in a lab, like I mentioned. And theoretically, by doing this, all we would need is like one cell from one cow, and that would be it. And we could get like an infinite amount of food that could feed everyone in the world. And the reason this is so much better is because when we can do this, is like we can reduce the amounts of emissions that come from the agriculture sector. So that's another way that we can fight to find ways to bring our carbon emissions to a net zero. So what other alternative energies are you excited about? I personally am super passionate about solar tech. And like I said, I think that is the key to the future. I really like, I'm really into like hydropower, because I know there's a lot of people looking into that these days. So I'm really, after I finish my research in solar tech, I'm pretty sure I'm going to go more into hydropower. So yeah. Do we have an oversupply of panels already? To be honest, that's something I haven't looked into, and I'm not exactly sure. But I do know that if we can increase the efficiency and get to truly 100% solar technology, solar efficiency, what we'll find is that we won't need as many solar panels, because they're already efficient enough as them. Where have you implemented your projects of solar panels already? So right now, I haven't done any external projects, mainly just research on my own and finding ways to understand it. But I do write articles on Medium where I do post like all the information I have in order to kind of, I guess, spread knowledge. And I also do try to come up, once I understand it more, I come up with proposals where I will try and send them to see if other people would like to, take on the proposal and see if it would work. So I haven't gotten to that stage with solar tech yet, but I will eventually once I get there. So yeah, that's where I am right now. And if anyone has any more questions, you can send them in. But right now, I'm actually really trying to understand solar tech as it is right now, because what I believe is that if we can find ways to, make solar technology more efficient, like I mentioned earlier, we can really like power the entire world. So, that's where I'm really focusing my energy on right now. If there are no more questions about solar tech, I'm going to be continuing just talking about alternative energy in general and like where we stand right now. So that I mentioned solar tech. So now we're like, if we think about wind power and all of that, a lot of people don't know, but a lot of wind turbines are actually powered from the electricity grid itself. Like a lot of them are actually, they need the electric grid in order to work. So what scientists are working on now is finding ways to make wind turbines much more efficient, and not just efficient, but like produce more energy, more electricity, so that they can power themselves and power the rest of the world. So they're also looking into like stuff like that. So that's what I know about wind power. And hydropower, like I said, that's going to be what I'm researching next after I finish my research in solar technology. So yeah, I think why? Okay, so solar technology, I think it's the key to the future. Like that was a question I got, because of the fact that like solar technology is what like I mentioned earlier, solar technology is the key to the future because it's the most efficient type of renewable energy we have now. So by innovating on that, that's the only way that we can really find ways to power our future generations. And that's why I think it's worth our time to invest more time, invest more research, invest more into looking into solar tech rather than trying to explore everything at the same time. So yeah, thank you so much for coming and watching this presentation. I hope you guys all enjoyed it. Like I said, my contact info was at the beginning of the presentation, and you can contact me anytime you want. So, and I'll be willing to answer any questions anyone else has after this. So that's all I have. So thank you.